Hey everyone, Mr. Newman here, and today we're going to do a quick review on how to solve equations. I expect this to be a review, so we will go real fast. Don't stress. If you don't know how to do all this, there will be ample time to relearn it the next few days, but I'd like to get started on this as quickly as possible. First of all, I want to remind you how to combine like terms. The way I do it, I like to look at like terms and draw symbols around them. Remember, a like term is any term that has a variable that's the same. So the 3x and the 4x both have x on them, so we can combine them. Notice when I'm circling these or putting boxes around them, I like to include the symbol in front, whether it's addition or subtraction. That way I know and I don't accidentally forget a negative. So 3x plus 4x is 7x, so we write that down. Then I'm going to circle the positive 5x and positive 7x, positive 5 and positive 7. So I'm going to add 12 there, and so we get 7x plus 12, and that's all we have to do here. Go ahead and try the next one on your own, and I'll show you how to do it afterwards. All right, for this one, 2a and negative 3a, see why I box the negatives? If you just box 3a, you might combine them and get 5a, but this should be negative 1a. Negative 1a is when you get 2 minus 3, you get negative 1. So when you combine those like terms, you get negative 1a for the a's. The b's are a different like term, so negative 3b and positive 4b. Those add together to get you positive 1b. And then positive 4 and positive 5, of course, gets you 9. Now, the ones are unnecessary, and you really should rewrite it without those. So we're going to have negative a plus b plus 9 be our final answer. Now, two-step equations, on these you're going to want to solve for the variable or solve for x, and I use GEMDAS. You might have heard of PEMDAS before, but I want you to notice the way I wrote it, because the M and the D stands for multiplication and division. Those happen at the same level, and the addition and subtraction happen at the same level. Those really just occur left to right in the equation, whichever one comes first. Now, I write this down because when you're solving, figuring out what some expression is equal to, we call that the order of operations, and the order goes from top to bottom. However, when you are solving for a variable, what you're actually doing is you're undoing the order of operations. So when you're solving, you're working backwards, GEMDAS or PEMDAS backwards. So let's look at this first one to apply this principle. So 2x plus 3 equals 10. A lot of you guys could probably solve it just because you've done so many of these anyway, but I want you to understand the why behind it. We have to get the x by itself, so we need to undo the 2 and the 3. The 2 is being multiplied, and the 3 is being added to the x. Which one of those happens first? Well, the 2 multiplying by the 2 will happen first, and adding 3 will happen later. So to undo it, we need to undo those in reverse order. We need to undo the plus 3, which happens later in GEMDAS. We need to undo that first. So we're going to actually subtract 3 first. And of course, you have to do that from both sides. So we're left with 2x equals 7. And now I can undo the 2 times x. Remember, a letter or a variable that's right next to a number, that represents multiplication. So we have 2 times x equals 7, and I'm going to undo multiplication with division. Another nice thing about GEMDAS is it kind of reminds you what the opposites are. The multiplication and division are opposites, and addition and subtraction are opposites that undo each other. So we get 7 halves. That is, of course, just one way to write it. You could also write 3.5, and both of those are acceptable answers here. For this one on the right, there are actually multiple ways to solve this, and it's very important that you know how to solve it both ways. So what I'm going to have you do is I'm going to show you the two-step equation way to solve it, and then in a little bit I'll remind you of the distributive property. So notice that 2 is being multiplied by the x plus 3. That x plus 3 is in parentheses, that's grouped. So you're going to actually need to undo the multiplication first because it's lower on GEMDAS. And when we undo multiplication, we divide by 2. So let's divide both sides by 2. We get x plus 3 equals 5. And undo the plus 3, we're going to subtract 3 from both sides. So we get x equals 2. Go ahead and take a moment and try the next problem on your own. All right, now that you've done it, let me show you how to do it. X plus 2, that is on a fraction bar that's actually called a vinculum. Strange fact. But what you can do is you can know that x plus 2 is actually grouped together. That's the G in GEMDOS. So that means I need to undo the dividing by 3 first. To undo division, we're going to multiply. So picture that x plus 2 in a parentheses, but that's just a reminder. You don't need to write that. To undo the dividing by 3, you're going to multiply by 3 on both sides. So we get x plus 2 equals 24. Then, of course, to undo the plus 2, you subtract 2 from both sides, and you get x equals 22. Now, you notice we have the exact same problem, and I need you to understand how to do it both ways, because there will be times where distributing is the easier of the two ways, and there'll be times where following GEMDOS is the easier of the two ways, and simply undoing operations. So here, the distributive property, of course, is when you're multiplying something in parentheses that is being added or subtracted. So here we're going to multiply 2 times x and 2 times 3. And you notice we draw the little lines on top to remind us of each of those and not miss any. And we get 2x plus 6 equals 10. Then we're going to follow the steps just like we did before and solve this equation. And we get x equals 2. Go ahead and try the next one on your own. All right, now that you've tried it, this does have 3 terms in that parentheses. It's called a trinomial. So we're going to multiply the 5 by all 3 terms. Make sure you distribute it to all 3. So we get 10x plus 20 plus 15x equals 25. And now we have to use our combining like terms skill. Notice I'm putting including the positive or the plus in front of the 15 inside my box. So we have 10x plus 15x is 25x plus 20 equals 25. Subtract 20 from both sides, and then divide by 25. And you must simplify fractions in this class. So 5 over 25 becomes 1/5. Or you may also write it as a decimal, which is 0.2. Now, when you have variables on both sides, there are lots of ways to solve these as well, but the one hint I will give you that will save you oodles of time is take care of the variables first, okay? Here I have 3x and 6x on each side, so I can't solve this equation until the x's are all on the same side, but I don't like to talk about or think about it in terms of moving the variable over, because that will lead you to make mistakes. So instead, I need to subtract out or eliminate the variable from one side. I could subtract 6x from both sides, but that would leave me with a negative coefficient. So instead, I'm going to subtract by 3x on both sides. So we get 5 equals 3x minus 13. And when I add 13 to both sides, 18 equals 3x, and we finish with x is 6. Go ahead and try the next one on your own. All right, there are a few different ways to do this. You could combine like terms first, or you could eliminate all the variables from one side first. I'm going to combine like terms first because I think it makes it a little bit easier. So 3x and negative 4x become negative 1x, and the 12 and the 2 get combined to become 14. Now this is a simple matter of either adding 1x or adding 5x to both sides to eliminate the variable from one side. And I chose to add 5x because that again makes the 4 in front of my x positive. It's just one less thing to mess up if you just try to take the extra care to make your coefficients positive if you have a choice. Now subtract 2 from both sides and divide both sides by 4, and we are finished with x equals 3. Just a reminder, on all these equation problems, you can always check your work by plugging the variable back into the original equation. And in fact, you'll notice on some of the practice worksheets and even on the assessments or quizzes or tests that we do, I'm going to require you sometimes to check your work in that way as a part of the problem. So, thank you very much for watching.